All right. So for today's lesson, the objectives are we will define factors that determine the polarity of a molecule and derive a definition of molecular polarity. Use this definition to describe the polarity of several molecules. This is a concept map just to give you an idea where we are so far. The unit is chemical bond. Today we are going to divide the covalent bonding into polar covalent bond and non-polar covalent bond. I like graphic organizer. If I was sitting as a student, I would copy this, but remember it will be on YouTube. You can always take your time and copy it later on, because the graphic organizer gives you a picture of where we came from, where we are, and where we are going. All right, so we already covered the three different types of bonds. Today we are going to divide covalent bonds into polar covalent bonds and non-polar covalent bonds. So I will move on since you can copy it later on. This is another graphic organizer I have made for you. Okay, Lewis diagrams. You already know how to draw Lewis diagram. Those Lewis diagrams, we also studied resonances. Okay, different ways to flip the single and double bond. We are talking about valence shell electron pair repulsion theory. The electrons will repel each other, and that's what determines the geometry or the shape of the molecules. That's what will determine the bond angles. That's what will determine the bond energy. Okay, what did we say about single and double? Which one will need a more energy to break? Is that single or double? Double, because double are stronger than single, and triples are stronger than double. You will need more energy to break them. We talk about bond length. Which one is longer? Is that a single bond or a double bond? Single is longer. Which one is longer, a double bond or a triple bond? Double is longer than triple. So today we are going to talk about polarity. You see how everything is connected. Everything is connected. The Lewis diagram will end the valence shell electron pair repulsion theory, will determine the shapes, bond angle, bond energy, bond length, and polarity. Here, covalent bonds are formed by sharing electrons between atoms. You already know that. However, not all covalent bonds are the same. Sometimes the electrons are shared equally. All right. Sometimes the electrons are closer to the more electronegative element. And we defined electronegativity sometimes last week. Electronegativity is what? The attraction an atom in a molecule has for shared electrons. Okay. Now, non-polar, this is what you need to know. Non-polar covalent is a covalent bond in which the electrons are shared equally or have an electronegativity difference of 0.4 or less. Can you pull out your electronegativity table? Did I give you a periodic table that has the electronegativity for each element? Can you pull it out, please? Okay, non-polar, no one is pulling more. They are sharing electrons, but they are sharing those electrons equally. Non-polar. Can someone tell me what is the type of bond that is found in bromine? What is the formula for bromine? You can talk to me. You can talk back. What? Say that again. Br2. What is the difference in electronegativity between Br and Br? Zero. What type of bond bromine will form? Is that ionic, polar covalent, or non-polar covalent? It is non-polar. Okay, if the difference in electronegativity is 0.4 or less, it is non-polar. No one is pulling more on the shared electron. They are sharing equally. All right? Yeah. Okay, it is 2.8 minus 2.8 equals 0. So it is non-polar. Now quickly check for me the difference in electronegativity between the bonds in CH4. If I draw the CH4 bond, which one would be the central atom in CH4? It is carbon. Okay, so I have carbon, I have hydrogen, 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 and I connect them. All right. Can someone tell me the difference in electronegativity between H and C, the absolute? Say that again. 0.4. 0.4 is the bond between C and H polar or non-polar? Non-polar, because we said from 0.4 to 0, it is non-polar. Non-polar, CH4. 2.5 minus 2.1 give you 0.4, so it is non-polar. Next, polar covalent bonds. Polar covalent bonds. The electrons are shared, but with an electronegativity difference of more than 0.4. If you check the difference in electronegativity and it is greater than 0.4, then you say it is polar covalent. And if it is greater than 1.67, it is ionic. Very, very polar. Greater than 1.67, it is ionic. What is the difference? What is the electronegativity difference in HF? Okay, I need for you to talk back, participate. 1.9. You said it is 1.9. Thank you. What type of bond is in HF? It is ionic, polar covalent, or non-polar? It is polar, because the difference is between 0.4 and 1.67. Therefore, it is polar. Some books will say 2, some book will say 1.7. Okay, so it doesn't really matter. All right, let's put the curtain down. To indicate the polarity of the bond, the first thing you do, you draw an arrow over the bond pointing to the element which is more electronegative. This shows the electrons are closer to this element. Now I need for you to look at this molecule. If I ask you to draw an arrow on top of that bond, would you draw it going toward fluorine or toward hydrogen? Toward fluorine, you're absolutely right. Because fluorine is more electronegative, so the electron is going toward fluorine. It's closer to fluorine. All right? It's like, let me give you an example. It's like we have, Alvin and Anthony. They put their money together and buy a little car. Okay? If Anthony put $75, Alvin put $25. They buy a little car for $100. I don't know what car would cost $100. So, if they are sharing that car, would it be fair for that car to stay 3.5 days at Anthony's house and half that time at Alvin's house? Where should that car spend more time? Is that Anthony who put $75 or Alvin who put $25? Anthony, that car should spend more time at Anthony's house. This is a pair of shared electrons. They are sharing. But this fluorine is more electronegative. It has more attraction for that pair of shared electrons. So those electrons will spend more time closer to fluorine than hydrogen. So we would draw an arrow going toward fluorine, the one that is more electronegative. All right. Okay, here's the arrow. Assign, the second thing you show, assign slightly positive. This is a lowercase delta, a Greek letter. We read it slightly positive and slightly negative sign to each element. Which one? Which one is slightly positive? Which one is slightly negative? Slightly positive, hydrogen. So I pull out, I drag the slightly positive charge right here and the slightly negative charge toward the fluorine, because fluorine is more electronegative. We said slightly negative because it is not really a full charge. They are not cation and anions. All right, so you show this, show the one that is more electronegative has a slightly negative charge toward it. Let's move on. Okay, what are the total number of bonds in, how many total bonds in water? You know how to draw water molecules. Look at your paper or draw it quickly and tell me how many, what is the total number of bonds in water? Bonds, water, look at your paper. You have your water molecule somewhere. How many bonds? I heard 2. Let's see. There are 2 bonds. The dashes, the line connecting the hydrogen and the oxygen, they are the bonds. There are 2 bonds. Okay. Next question. How many bonds are polar? How would you know if the bonds are polar? You check the difference in negativity between the hydrogen and oxygen. Quickly tell me what is the difference. 1.4. So how many bonds from the water are polar? Say that again. Both of them are polar. Let's see. Both of them are polar. I'm sorry, it is non-polar. 0 are non-polar. 2 are polar. Okay, there are only 2 bonds. Both of them are polar. How many non-polar? 0. And then draw the water structure showing the polarity. Can you quickly draw and show me which one would be partially positive, which one would be partially negative? The arrow would go toward which one? Oxygen. And where would you put the partially positive sign? In hydrogen. And the partially negative would be in oxygen. Okay? This is the way you should have the water molecules. Alright? It is H2O. It has 2 pairs of unshared electrons. It has 2 bonds. And the arrows will go toward oxygen, which is more electronegative. And then the partial positive charge on hydrogen, the partial negative charge on oxygen. Next. Now, can you quickly draw C2H6? C2H6. What are the total number of bonds? Do I have an answer? I heard 5. Let's see if you are right. Because you have 2 carbon, there is a bond between each carbon. Alright, and you have 3 chlorine around each carbon. The 2 carbons have a bond between them, and you have 3 chlorines on each carbon. Give you 7 bonds. 7 bonds. How many of those bonds are polar? How would you answer that question? What is the difference in electronegativity between carbon and chlorine? You say 0.4, 0.5. How about, what other bonds do you have? Carbon and carbon. So how many bonds are polar? 6. Let's see. You're right. How many are non-polar? One. The one between carbon and carbon is non-polar. How would you draw? You already draw it, showing also the partial negative charge. So this is the way you should have the C2H6. C2H6. Carbon is partially positive. The chlorines are partially negative. The arrows would go toward chlorines because they are more electronegative. So that's the way you should draw it. Okay. Let's see how you would draw this. What are the total number of bonds in C2F4? Who can tell me? Say that again. Let's see if you are right. Great job. And thank you for participating. Great job. How many bonds are polar from those bonds? 4 are polar. Let's see. You are right. And which one is non-polar? Between the carbon and carbon is non-polar. And draw the structure. This is the way you should have it. But something is missing here. What is missing here? Well, I think if you draw it properly, you need to have a double bond between the carbon and carbon. Because look at that carbon. It's not stable. You have 6 electrons. You need a double bond here. So make sure you draw it right. But the carbon is more electropositive. The fluorine is more electronegative. Now, I'm checking. You have your electronegativity table out. Help me come up with the answers. Is the bond between boron and fluorine polar, non-polar, not enough information, or ionic? Polar. What is the difference in electronegativity between boron and fluorine? 2. The difference is 2. Oh, this is very high. Wow, it is very high. So I would even say it looks like it would go with close to ionic. But boron is not a metal. All right. Now, here's another concept. Pay very, very close attention. A different concept. Okay, be patient. I will give you time to work with a partner. All right, be patient with me. I need to cover this. The presence of polar bond in a molecule may or may not cause the entire molecule to be polar. A polar molecule means that one entire end of the molecule is partially positive and the other end is partially negative. I know I don't have space between the words. I try. I put the space and then they came together. Okay, the letters came together. I spent my time yesterday doing this. Now, this is what it means. A demo I always do every year, but we don't have time now. Just imagine. The presence of polar bond in a molecule may or may not cause the entire molecule to be polar. A polar molecule means that one entire end of the molecule is partially positive, the other one is partially negative. I need for you to look at this one. Because this is more electronegative, it will be pulling on this side. Because it is more electronegative than hydrogen. But let me show you another example. Is the bond between carbon and oxygen polar? Is the bond between carbon and oxygen polar? Help me guys, I'm almost done. Is the bond between this carbon and this oxygen polar? Is the entire molecule polar? No. It cancels out. Do you understand? So those are the conditions for a molecule that has polar bond to be non-polar. I'm going to summarize this note for you. Let me just summarize it. I know it's a lot. You won't have time to copy all of this. But the good thing is you can watch it from home and pause it. Do whatever you want with it. Now, let me just summarize it for you. Whenever you have a molecule, if the atom around that central atom, those atoms are the same that are around that central, and that central atom has no pair of unshared electrons, know that the molecule as a whole will be nonpolar. Do you understand? All right. So if we read all of this, that's what it means. I will continue. Now, how many polar bonds are in carbon tetrachloride? How many polar bonds? I heard 4. Okay, let's see if you are right. Where's my okay, 4. Is the molecule itself is polar or non-polar? Non-polar. Even though the bonds are polar, the molecule as a whole is non-polar. Okay, almost there, almost there. How many polar bonds are in carbon dioxide? I heard 2. Is the molecule itself polar or non-polar? It is non-polar. The polarity cancel out. They call it a dipole moment, cancel out. How many polar bonds are in ammonia? 3. Is the molecule itself polar or non-polar? It is polar, because there is a pair of unshared electrons on nitrogen. The molecule is not symmetrical, so we still have a pull on one side of the molecule. All right. Now, can I have a volunteer to come here and pull out? Okay, come here. Pull out molecules from that box, and then the class will tell you if they should put them in under polar or non-polar. Just put your pen and pull out. Let's see. Hold it up so everybody can see. Bring it all, but don't let it go. You have to hold it down. Is that polar or non-polar? Polar or non-polar? I would say, okay, put it under polar. Because they are not. I hear the noise. Okay. So the molecule as a whole is polar because they are not the same elements. There is a difference in electronegativity. Okay, pull out more. Polar or non-polar? Non-polar, same element. The polarity cancel out. I hear a lot of noise. All right, next. Polar or non-polar? Polar. It is not symmetrical. There is a pair of unshared on the central atom. All right. Polar or non-polar? Polar. All right. All right. This is C and N. Polar or non-polar? Polar. Okay, next. This one is interesting. Polar or non-polar? What is it? Non-polar. There is one central atom and all the terminal atoms are the same. Do we have more? Polar or non-polar? Non-polar. There is a central atom. All the terminals are the same. I think we have enough. Thank you. The noise is killing me. All right, next. How many of the following molecules are polar? Can you quickly check your electronegativity and tell me which one are polar? Come on, guys. I heard CH2O polar. What else? CO. What is the difference in electronegativity in CO? 1. Polar or non-polar? Polar. Now, in order for you, is N2 polar or non-polar? Non-polar. The difference in electronegativity is 0. To answer this question, what would you have to do to answer the question for PCl3? You need to draw the Lewis structure. You need to draw the Lewis structure if what? If there is a pair of unshared electrons in phosphorus, then it would be, if you have dots on P, it would be polar. All right? I will stop here for now.